Alright, this is section 8.1, polar coordinates. Let's take a look at what this is. So to plot points using polar coordinates. So consider the point P with coordinates xy in the coordinate plane. In polar coordinates, that point is given as the point P with coordinates r theta. If r is greater than theta, then P lies on the terminal side of theta. That means you would kind of like if you were graphing theta, yeah, you would follow that angle, and on the terminal side of that angle theta is where the point is. Alright, and if r is less than theta, then P lies on the terminal side of theta plus pi. So you would again rotate to theta, but then you would go 180 degrees across. The ray pointing in the opposite terminal side of theta, a distance absolute value of r from the origin. Okay, so whatever distance that is. Okay. From the positive x-axis, theta is greater than counterclockwise. That means that way, like we've seen it before, and negative in the other direction. All right, the origin is called the pole. The positive x-axis is the polar axis. Let's look at the example. So we're going to plot the point 2 pi over 6. So 2 pi over 6 is on the terminal side of pi over 6, a distance 2 from the origin. So the way I would do it is I would mark off 2 and then rotate that pi over 6. So that should be that point right there. Alright? Alright. And we'll do the other one in class. Let's go to part 2, converting ordered pairs between polar and rectangular. So to convert r theta to, that means from polar to rectangular, use x equals r cosine theta and y equals r sine theta, right? So notice we'll have r and theta, and we'll just substitute. To convert xy to r theta, use r squared equals x squared plus y squared. That'll be a little bit tougher. And tangent theta is y over x for x not equal to 0. Okay, so let's look at first converting one of these. We'll do letter B. We're converting from polar, right, because you're given r and theta, to rectangular. All right. So to convert from polar to rectangular, x is r cosine theta. So this will be negative 2 cosine of negative 2 pi over 3. That's r cosine theta. And y is r sine theta, negative 2 sine negative 2 pi over 3. Okay, and we can actually check, we'll check after we find these, we'll check to see where that point would be, just following what we know from up here. Okay, so cosine of negative 2 pi over 3, I need to know where that is. So negative 2 pi over 3 would be in this direction. Yeah. So about right there. So the cosine is negative 1/2. Sine is negative root 3 over 2. Okay, that's the rotation, by the way. It's not the point. That's just the rotation. Right? I'm looking maybe at the unit circle, right? If we look at the unit circle, this is negative 2 pi over 3. All right, so just to find out what cosine and sine of negative 2 pi over 3 are. Okay, so this is negative 2 times negative 1/2, comma, negative 2 times negative root 3 over 2, which will be the point positive 1, comma, square root of 3. So that's where the point actually is, right? 1 square root of 3. So that would actually be over here somewhere, right? But 1 square root of 3. So this is the unit circles we have there somewhere. All right, but if we draw a new coordinate axis, 1 square root of 3 would be 1 square root of 3 is like 1.7, so about right there would be the point. Okay, does that match with this? So negative 2 pi over 3, remember when r is negative, right? So if r had been positive, we would have gone that distance and negative 2 pi over 3. But when r is negative, it's actually on the opposite side. So it's actually up here, the point itself, right? So if this distance is root 3, what is it? Negative is 2. If the radius of this circle is 2, so the angle is over here, but the point is actually over here, right? Because it's a negative r, or r is negative. Okay, let's go on to some others. Let's try number 2, and we'll do B. And B said, and we're converting, given rectangular and converting to To polar. All right, so I want to see where the point is. So the point, if I consider 2, -3, 1, 2, -3 is down here. Okay? Now, I want to consider the angle theta, right, that has a terminal side at that, that goes through that point. Yeah? And so remember, this is the angle. We can find tangent inverse because tangent theta is -3/2. So tangent inverse -3/2 is the angle, right? So theta will be tangent inverse -3/2. Except when I plug that into my calculator, it gives me an approximation. It's about -56.3. So I can't use an approximation. How do I give an exact number? Well, that's it. Tangent inverse -3/2. Yeah. So this, I can write this then as 2. Oh, I'm sorry. No, I need to find what is the R, right? So R, I don't know if you guys remember, this is something familiar, right? R is the square root of x squared plus y squared. Yeah? So that would be the square root of 2 squared plus -3 squared, that's 4 plus 9, that's square root of 13. So this is the square root of 13, that's R, comma, and theta is tangent inverse -3/2. Remember though that that's a negative angle measure, right? All right. If we want to find with -√13, right? So that's 1. That's with R greater than 0. With R less than 0, this would be negative square root of 13 comma, and then how do we find this angle? And we already saw it over here. It's on the terminal side of theta plus pi. So the rotation is theta plus pi. Theta plus pi, so it'll be pi plus tangent inverse of -3/3/2. We could write that as -1.5. Okay, and so those would be the coordinates. And if you consider pi plus tangent inverse, it would be up here, right? But since we use the -√13, then it would be on the opposite side, which we take us back to over here. Okay, all right. Let's try part 3. I'm sorry, part 3, converting between polar and rectangular equations. Okay, so a polar equation is an equation described in a polar coordinate system with variables r and theta rather than x and y. So x and y is for rectangular equations and r and theta is for polar equations. Okay, remember for these, cosine theta is x over r, which can also be written as x equals r cosine theta, right? Sine theta is y over r, which can also be written as y equals r sine theta. And x squared plus y squared equals r squared. For rectangular, we usually write y equals when we have an equation. Don't have to write, but we usually see it that way. And for polar, r equals. All right, so let's try letter B. This one right here. Okay, so for number 1, we'll leave A for class and we'll do this B. And by the way, this one we're going to leave for class. Okay, so this one right here. So y, remember y is r sine theta. So I'm going to write r sine theta equals x squared, and x is r cosine theta. So this is r squared cosine squared theta. All right, I'm going to move the r sine theta to that side. So I'll have 0 equals r squared cosine squared theta minus r sine theta. All right, I'm going to factor out in r, so I'll have 0 equals r times r cosine squared theta minus sine theta. All right, let me move this in a little bit so you can see it better. There we go. Just a little bit better. All right, so it's r cosine squared theta minus sine theta. Okay, and we factored out in r. All right, so when we factor out and we have 0 on the other side, we can separate these. This would be r equals 0 or r cosine squared theta minus sine theta equals 0. Okay, so r equals 0 is a that means that it's a circle with no radius, or x squared plus y squared equals 0. All right, but this one, if we move the sign to the other side, we'll have r cosine squared theta. I'm just solving for r, by the way. Equals sine theta, cosine squared theta equals sine theta. And if I divide by cosine squared theta, I'll have r equals sine theta over cosine squared theta. And if I think about that, sine over cosine is tangent. And then times 1 over cosine. This is sine over cosine times 1 over cosine. Times 1 over cosine is secant theta. So r equals tangent theta secant theta. Which includes r equals 0, right? Tangent theta secant theta is a parabola, yeah, that includes that point. All right, let's go on to number 2, and we'll do number 2. We are going to do 2b, and I think we're going to put it on a separate video. So I'm going to stop this one here, and we'll pick up on 2b on the next part.